And now I introduce Kevin. You all see is Kevin, not the Kevin from yesterday, Kevin from this morning. And now Kevin inspire us with test containers.
Yes.
Feel free.
Thank you. Good morning. Woo. Okay, so is it working, the microphone? Yes, okay, cool. All right, my talk will be about test containers, and I call it a year in review, or maybe we will look a little bit further than a year even, so a year or more in review. To get a feeling of the audience, who of you knows about test containers? Oh, that's nice, that's nice. Who of you is using test containers? Oh, it's also nice. Who of you are developers? So quite a lot. And Java developers? Yeah. So I think this talk is most useful in general for people that already know about test containers in a certain way, about developers, mostly maybe Java developers, that can learn a bit about the way we are currently developing this library, this project. For the others, it's maybe also interesting to see how a timeline of an open source project develops in certain ways. So first, some words about me. Yesterday when I had the lightning talk, I skipped the introduction, but now it's coming. My name is Kevin Wittek. I'm currently a doctoral researcher at the Institute for Internet Security at the Westphalian University of Applied Sciences, very nearby here in Gelsenkirchen, where I am head of the blockchain research group, blockchain research lab it's actually called. Yeah, so I used to work in industry. I even used to work here at GData, first at the GData main company, then later at GData Advanced Analytics. And yes, it was always a great time, and therefore it's also really happy for me to be back here, standing here on the stage at the GData campus. Very cool, and having this nice welcome, this nice atmosphere. You've all seen the campus, how cool everything is, how good the coffee is, and the food, amazing. In addition, I'm also a kind of self-employed consultant, freelancer with my own company, Microsoft, where I sometimes do coaching, mentoring, workshops, whatever you want. Also about test containers, if you have an interest about it. I'm one of the test containers maintainer, in general, a big open source fan, Oracle Groundbreaker ambassador, yada yada yada. Yes, this is the logo from the institute. All right, and thanks to Sergey, who is one of the other test containers maintainers, and he was the first one to give a similar talk, also give me the inspiration to this talk, and I copied, or I got inspiration from some of his slides as well. So I like to get some motivation into testing by telling a small story from one of my former projects, and yeah, we did testing, we did a lot of unit testing, some mock testing, but maybe not enough integration testing, because in the end there was a production issue basically, where we ended up here. We ended up in a, how you call it in English, cow shack, like at a farm with the cows. And how did this happen? So we were developing this Java server. It was the business server for a milking robot system, basically. So you have those automated milking robots that automatically determine how much food to give a cow, how much to milk it. There's a pretty interesting business logic involved in this, and you have this client-server component, the server where you can manage all the stuff. And yeah, we had a lot of tests, and integration tests in this case meant you really had to go into a workshop where they had these robots and like artificial plastic cows and so on, and integration testing you would do with the robots, so that was pretty cool. Yeah, but at one point we got a call from one of the farmers where we had the beta installation, the test installation, and he was saying, oh, something strange is happening, my food is empty all the time, or like the special food. You get like, you give the cows normal food, and then they get some special power food, so they get more milk and more motivation to give milk. And the special food was empty all the time, and we said, okay, strange. Then we looked into the logs, and then we saw, oh yeah, right. Every time a cow comes in this robot, it gets the maximum portion of the food, which is not how the business logic was supposed to handle it. It would handle it according to the last visit and so on. And there was kind of an off by one error. So basically thinking all the time, oh, the cow has never been here. please have the maximum. And it was going on like this for a couple of times, and at one point the food was gone. And yeah, it was a bug in a SQL query. So we had some extensive tests, but like mocked away this integration layer, this database layer. So the bug in the SQL query was not found. It was a lot of debugging. We fixed it, and it was debugging in this workshop room while the robot was running next to you, super loud. It was a crazy situation. And yeah, then we had the update. And how do you update a server component for a milking robot? So there is no over-the-air updates. There are no online updates. You have to drive to the farm and go with the cows, because the server is also standing there next to the cows. You're standing in the cow shed with a USB stick and updating the JBoss. Yeah. That was cool, but then I said afterwards, oh, come on, guys. So let's please do more testing. I don't want this to happen again. It was kind of fun, but I don't have to have a repetition of this. So yeah, that was a little bit motivational story. In general, we assume this is kind of a maybe common knowledge, or how people would argue and think an ideal testing pyramid looks, or how people in the 90s said or in the 2000s said an ideal testing pyramid should look. You have mostly automated unit tests. You have some integration tests, this middle layer. Also, we don't have a clear definition. What is an integration test? What is a component test, system test? But some kind of middle layer that interacts with external systems. You have UI tests at the top, end-to-end tests. Sometimes they are called acceptance tests, whatever. A lot of automation, definitely. And at the top, you have manual session-based testing, real explorative testing. That's what the testers should do, like real creative, good testing. So there is some discussion in the industry that this is an ideal testing pyramid for your test suite. And when I'm talking test containers, I'm talking about integration tests, so this middle layer. And so since this definition is not 100% clear for the course of this talk, we use the definition that those integration tests are the tests that interact with external system dependencies, things like hitting the file layer, the file system, hitting the network, and so on, or launching application servers, interacting with the database. Obviously, integration tests. And yeah, this pyramid is kind of accepted, but maybe accepted in a certain way as part of a cargo culture. Not sure about this, but maybe it's interesting to rethink if we need a pyramid or if the shape could be different and like nicely in line with all those bees from B42 we always had and the honey. We can think about a testing honeycomb. So instead of a pyramid, we have this diamond shape, honeycomb shape, where we have less unit tests, they are called implementation detail tests here, then quite a lot of integration tests and some integrated tests. And this testing honeycomb, I didn't come up with it. It's from Spotify, from a blog post from Spotify, now nearly 2 years old, and or over 2 years old, yes. And there they described how they test their microservices like this, and they make an explanation that their microservices have a considerably larger integration surface as compared to the actual business logic code inside. So therefore they say it makes more sense for them to have more integration tests. And since it's still microservice, they are still fast enough to run. But then they said it's important that you really have integration tests and not integrated tests. And it was the first time I stumbled upon this concept of integrated tests in this blog post. And it's a real valuable thing to have in mind. And any one of you heard about this concept of integrated tests before? Yeah, oh, Jan, very good. So I will shortly explain the definition, or give the definition of integrated test. And it was first referenced in a blog post from J.B. Rainsberger, who is very well known in the TDD community. And he defines it as follows. I use the term integrated test to mean any test whose result, part or fail, depends on the correctness of the implementation of more than one piece of non-trivial behavior. So this is an integrated test, and they are an anti-pattern. You want to have as few as possible for them. And a little bit easier explanation by Spotify would be a test that will pass or fail based on the correctness of another system. And those tests are those kind of flaky tests, those tests when you run the test, then you think like, oh yeah, sometimes this fails, we just rerun, then it works, or like someone else broke something. So you really want to avoid those because then you can't trust your test suite anymore. So concrete examples for those integrated tests are things where we have to manually spin up something. For example, locally, we have to locally have a Postgres database running to do the testing. If you forget this, your tests will fail but no, your tests didn't fail because you changed something of your code. It's changed because you changed the environment. You forgot something. And then you can't know, okay, did I break something with my changes in the code, or did I just forget something to set up my system correctly? And yeah, even worse maybe is if you have a shared testing environment, you're sharing with your colleagues, with other teams, and you have those kind of effects where someone else maybe runs some database migrations, and then you have suddenly missing columns or whatever, and then you can sometimes reach these points where if those tests in those environments fail, you will first say, oh no, probably I didn't do something wrong, probably the other team broke something, so it's usual, they always break it every Thursday, we will not investigate further. And this is of course very toxic for trusting your own test suite and getting confidence in your test suite. At the same time also, if changing your system breaks other systems, so this is also mostly the case if you're running one integrated testing environment for all of your services. Maybe you have a microservice, you always deploy the latest version, you change the API, then you break the test of the other people, so you don't want to have those things happen. And yeah, test containers is ideally something to move a lot of those integrated tests to real clean integration tests. And then integration test becomes nicer in general, I would argue. And yeah, here I have a small slide kind of showing a little bit of historic development, how we moved forward with more modern tools, how modern tools changed our way to approach integration testing. And one could argue that classically the way to integration testing was still using mocking. And then even you can wonder, is it still integration testing? But back then it was much more expensive to run even databases locally, or you maybe just had one big shared mainframe database. So the only thing you could do was mock away the databases. Then, yeah, at one point local databases became cheaper, so you can run a Postgres locally. You can use a replacement database, something like H2 and so on. So that's in general already better, I would argue, than mocking, in my opinion. But at the same time, they often behave still differently, like H2, even in a compatibility mode to Oracle, behaves differently than Oracle in subtle ways. And this is like, again, leading to you not being able to sometimes trust your tests. And at the same time, we have this situation still in integrated test because we have those local databases very often set up beforehand in a certain way. We later had the rise of using virtual machines to contain our complete development environment, or maybe just the components necessary for integration testing with things like Vagrant. I think that makes things already much better, but sometimes Vagrant also was a little bit slow, virtual machines a bit more overhead. Then Docker came, or containers came, with Docker as the poster child of containers, and that made things, I think, much more accessible, and it kind of unlocked a new potential in the way we can approach integration tests. Then Fig was released, now called Docker Compose, even maybe a nicer way. Yeah, nowadays, with things like test containers, we can maybe move in a direction where we are not using like those tools in between, like Docker Compose or Docker, but directly interact with the Docker API from our test by means of a library, maybe. Yeah, so the problem with especially using Docker Compose is with the declarative YAML, which is in general quite nice. There are some real drawbacks, because what we see here, if we have this kind of port mapping, we directly automatically get an integrated test, because we are mapping to fixed ports. And yeah, what happens if those ports are already used by another service? What happens when I try to parallelize my test suite, my test runner? I want to have multiple of those instances. First, it's in the first instance, it's not supported by this kind of concept, so I have an integrated test already. Like running this Docker Compose up, it will fail if the ports are already in use. And depending on how I integrate it with my development cycle, maybe initializing the Docker Compose up already an integrated factor, since I have to do this manually. But there are ways to automate this, of course. Yeah, so again, like container per test, we have normally the same container for all tests, which is sometimes good because it saves time, but sometimes I maybe want to have explicitly a specific container for a certain test. And Ide Integration, again, depends on how you automate the setup of those things, but can be potentially not so easy. So maybe you have it combined with your Maven lifecycles, then you have to execute it over the Maven to get those things up. But in general, I think a good developer experience allows you to launch unit tests or JUnit tests directly from your IDE. All right, and yeah, this is also an interesting aspect. So in general, when you use such an approach with Docker Compose, you would normally expect the services, the containers, to be accessible over the map port on localhost. And in many instances, this will work. But how do you know that Docker is running on your machine on localhost? So there are ways to configure a Docker environment, a completely valid Docker environment, where the Docker daemon is running somewhere else. So things like Docker machine, certain CI environment setups. Therefore, like statically coding that you want to access a container on localhost, not the best idea for portability. All right, and so Testcontainers tries to solve a lot of these problems. And that's how it looks. A simple example from the Java code, the Java API. So yeah, kind of object-oriented Java API. You can instantiate containers. You can just start and stop them, how you would expect maybe an object-oriented API to work. And for those of you who were in the workshop on Monday by Open Knowledge, they really dived very deep in all the features of Testcontainers, so I will not go that deep, but I will try to show you more some of the recent developments we had in the library. Okay, the project, first of all, it was released 2015 by this guy, Richard North. Back then he was still working in Japan, and it's 100% open source. It's under MIT license. I'm pretty sure it will remain 100% open source in the foreseeable future, so there are no plans to go any other route. We have a lot of releases, a lot of contributors, but mostly 3 main maintainers. It's the core maintainers team. That's Richard. That's Sergey from, he used to be Pivotal now VMware, of course. Yeah, and me. I joined as a third person, and it's mainly a Java project. Testcontainers Java is a Java project, as the name says, but we have forks in other languages. It's mostly re-implementation because there is no concept how to share code between the different languages. So they try to follow the same paradigms and re-implement them in the other languages. And therefore, feature parity to Java is not always given. But I think the Go one is pretty far. We have a .NET one. It's not mentioned here, but that's also, oh yes, C#, that's also pretty far developed. I think there is a big refactoring coming up. So if you're using another language, you want to use Testcontainers, give those forks a go, but your mileage may vary. Yes, yeah, in general, a lot of features in there, support for generic containers, specialized support for often used components like databases, all those relational databases you can think of, stream processing components like something like a Kafka, Pulsar. We have support for Docker Compose if you want to reuse your existing Docker Compose. Also for UI testing with Selenium. We now have chaos testing with ToxiProxy. Yeah. And yes, the important things that Testcontainers brings to the table are, first of all, using the dynamic port bindings, the feature that already is built into Docker, just publishing on a free port instead of mapping to a fixed port. And then we have a easy-to-use API to get the actual map port after the container started. And the other thing I want to highlight is that we have a concept called wait strategies. And that's also pretty important for stable tests, because the problem if you're just like in a naive way launching a container like, say, a Postgres, and you say, okay, after I launch the containers, I will interact with the container, with the database, you get into the problem that launching a container is not the same than launching the application inside the container. So it takes a longer time for the application inside the container to be ready so that you can interact with it. And yeah, depending on the actual implementation and the container implementation, you have to have a different strategy, how you determine that the application in a container is ready. And Testcontainers provides an API for this and different kind of wait strategies. Simple ones being you check that you get a certain HTTP response from a certain endpoint. You can check just that the TCP port is open, that a certain message has been logged, or you can even check if you have a Docker health check that just the health check is healthy. or you can build your own. We have for the JDBC ones more sophisticated, where you can check that you can perform a JDBC query against the database. And this gives you a good confidence that the application is in a ready state then. Works on all platforms and all Docker environments that are supported by Docker, so therefore automatically works on things like Docker Machine, those Docker for Mac, Docker for Windows that have their own specific differences to running Docker on Linux. And Testcontainers tries to work out of the box. You don't have to configure anything. It performs some environment discovery to understand where it's running. And in general, if Docker works on your command line, then Testcontainers should work out of the box. So works on all platforms, yeah. Yes, on Windows, JDK 13 works. A lot of now companies using it, open source project using it. They're pretty heavy about this. We have integrations in different test frameworks. This is Spark, this is JUnit 4 integration, JUnit 5. Okay, but that's not what my talk is about. And here we see the growth of stars. So I don't know, is this moving towards exponential? I don't think so. But still, we are over 3,000 stars now. That makes me pretty happy. And I think for a Java project, that's good. For a JavaScript project, it would be like nothing. But for a Java project, it's not bad. So we're on a good track. All right, I will quickly show you how it looks in practice. So, yeah. I have this JUnit 5 test, JUnit Jupyter, and it's like a super, super easy test where I just try to integration test my repository class, my repository object. I have a book repository where I can save books, so yeah, super easy example. And I have 3 tests here. One test, empty repository is empty. When you save one book, you have one book in a repository. You can save multiple books, and then you can search for them. And the actual Testcontainers integration you can find here. It works with the JUnit 5 Jupyter extension. So you see the Testcontainers annotation. You see the add_container annotation means this class, this field in this test class is now managed by the Testcontainers extension. And here in the setup phase, I'm using a tool called Flyway. Flyway in the Java world, very well known to handle database migration. So I just do this for the initial setup of the database schema. Okay. And when I run this now, in the way it's defined here, it would create a new database for every test. So a new database container even. So therefore it takes some time. Yeah, so each test roughly like 4 or 5 seconds. Yeah, and this of course slow. It's not perfect, but for getting a brand new database instance every time, including launching the database, I think it's okay. And here is a trade-off. In general, this is just now a demo, so it's not how I would recommend you do it. You should not use a new container for each of your tests because it's slow. It slows things down. This is solving test pollution on the infrastructure level. You get a new infrastructure for every test. It would be better in general to solve test pollution on a logical way. On a logical level. Create a new schema, already much cheaper, or try to clean up your test afterwards. But this is a trade-off you have to find. Yeah. And there are ways to use test containers in ways where you reuse the same container all the time. And later I will show another demo for giving you even faster development feedback while using test containers. All right, and okay, so you didn't actually see what is happening in the background, so 1 second. Okay, so here we see, yes, this container is started, and I think we got already a new container now. And again, new container, so every test we get a new container, all happening in the background. Cleanup is happening in the background. We have this Reusable Sidecar container doing the cleanup. I will tell a little bit more about this in a second. But yeah, that's test containers for you in a nutshell. All right. So, now, what I actually wanted to focus on is like showing you a little bit the changes in the releases over the last years, what features we got into test containers. So we just try to quickly step through the last year, a little bit longer than last year actually, because it starts actually like 2 years ago. And here we introduced those Reu container I showed, Reu sidecar container. It was in version 1.6. And this was a really crucial design decision for test containers. So what does this Reu container do? It's responsible for the resource cleanup after the test. So when the containers are not needed anymore, when the JVM exits, it removes all those test containers, resources like containers, like images, like volumes, you say whatever you want. And before we introduced this concept of a sidecar container, we had a JVM thread for doing this, which was working in a lot of instances, but in some instances it was not working. So we had a shutdown hook registered, so in case of a shutdown it should clean up all the containers, but sometimes they were like still lying around there. And why is it? Because if you sick kill a JVM process, you will not execute the shutdown hooks, then you end up with a lot of zombie containers, whatever. And this is a situation you could very easily run into when you were like debugging, and from the debugger just kill the application because you were not interested in the debugging anymore. Or if you run in CI, you cancel CI jobs, and some CI runners might just sick kill your process, and then you had many like zombie containers on your CI at one point. So not cool. And the best way to solve this, like introduce an additional container, like solve every problem with an additional container. It's a good pattern probably. And yeah, we have this small Go binary that runs in this tiny sidecar container that now handles this. The JVM sends heartbeats to this container. Once the heartbeat stops because the JVM had got killed, it will just clean up all test containers resources. Yeah, and also we got Kafka support. In the next version, 1.7, we got support for Maven bombs, Maven bill of materials. So if you are using multiple different test containers modules, you can just use the Maven bomb instead now, and then you don't have to specify the version numbers of each test containers module. Yeah, with Gradle, now it's also support Maven bombs. And for mock server, which some of you know, like you can use mock server for integration testing, like simulating an external HTTP server. We got a module that's now built into test containers. And for Docker Compose, you can see some examples here. We also supported now wait strategies for the services in the Compose. Like before, we just had a super naive wait strategy implemented, like wait for the port to be ready. Now you can use the full feature set of test containers wait strategies also when you're using Docker Compose. So I think this is very crucial when you want to have a stable setup with Docker Compose and test containers. Okay, yes. Next, we in 1.8 we introduced OKey HTTP as a transport client for communicating with the Docker socket. Before we were using Netty, and then OKey HTTP made things a little bit more easy, but it was just like experimenting. So at this point, we added support for this, but we were not doing much with it. We extracted test framework agnostic interfaces. So before, everything was very closely tied to JUnit 4. Now we tried to be more agnostic, make it easier for other frameworks to integrate. So now we have the startable interfaces that containers can implement, and that we have a startable interface that containers implement, and test framework integrations can now use the startable interface. We got support for Docker credential helpers. I'm not even sure what those credential helpers do exactly. So they are like from the Docker installation binaries, or they are a way to use operating system dependent credential stores. Like you have a different credential store on Mac than on Windows for your Docker hub credentials, for example. And there we got support for using them, leveraging them. So when you pull from a repository where you have to be authorized. Copy file to container feature is very cool. We can see the example here. This means you can you don't have to mount anymore files into containers, and that's very nice when you run in CI setups where you run, for example, with a Docker wormhole pattern where you are mounting your socket into your CI container, and if you would work there with bind mounts, you would bind mount into the host. But if the CI container checked out the source code into the CI container, bind mounting from the host is useless for you. So using this copy file to container just copies them via byte stream, basically using the Docker CP command, and that is in general much more robust. Yeah, support for new modules like Apache Pulsar support now in their Couchbase Cassandra. Then I think release 1.9 was a release where we got Windows support really working well. And that's in many ways thanks to using now OK HTTP as the default transport. Because on Windows, Docker for Windows, on Windows 10, you have the problem that the Docker client is communicating with the Docker daemon not using a socket, but using a Windows named pipe. So therefore, many tools said if you want to use our tool on Windows, you have to set this checkbox here, expose daemon on TCP without TLS. You could do this in the Docker for Windows UI. And that's, of course, not cool and not secure in any way. And you have to know this. So you have to know that you have to configure your Docker daemon or your Docker for Windows in a certain way. And thanks for getting named pipe support working. It now works out of the box. And in this whole effort, in this version, we try to also fix all those tiny paper cuts you would get when working with Windows, getting registry authentication support working on Windows correctly, and with the local compose, so with Docker Compose, getting it working correctly, because when you're on Windows, you have Windows file systems, and they sometimes behave in subtle ways different than Unix file systems. So, yeah. And this feature is also pretty cool, is host ports exposing. So if you, for example, want to launch your application, your Java application maybe on localhost, and then you want to have a container that interacts with your application you're running in localhost and not the other way around, you can now use this expose host ports feature in Testcontainers. Then this port becomes accessible to the containers in their network under this specific URL. Yeah. Right, next release, still 1.9. Yes, still 1.9. We got some other stuff going. Couchbase modules first only worked with fixed ports because some applications are not working that well with those dynamic port bindings. They sometimes need and want to know before they start on which ports they are running. But here we got it working somehow with support from Couchbase people, like they got involved in this. This was very great. Some new modules, ClickHouse, I don't even know what this is. PostGIS, which is a special Postgres version that supports more geospatial features. All right. Then with the version 1.10, we got JUnit5 support in there. We did a complete relaunch of our documentation. And now our documentation, all the source code examples you can find in our documentation come from the actual source code, come from the actual tests. So you can see it looks like this here at the bottom. So we have a markdown, we're writing markdown for our documentation, and we have code includes going into the tests. So yeah, you can be sure that the code examples in the Testcontainers documentation are working because they are part of our own tests. This feature is not that well known for many, but it's important to know. You can disable this Rio container I've showed you, and you have to do this on certain environments, in certain more locked down CI environments, because the Rio container needs to mount the Docker socket, and there might be CI setups where this is not allowed or not possible, and then it's sometimes the only way is to right now disable the Rio container. And Bitbucket is such an example. So Bitbucket CI, at least the cloud one. But there also it doesn't matter because all the build instances are ephemeral, so they get deleted afterwards. After all, so it doesn't matter if Ryuk is not cleaning up because they throw away the whole build environment. Support for using things like SHM, TempFS, SHM sometimes needed for like bigger containers, like a Chrome container and so on. We started using Dependerbot. New modules, Neo4j and Elasticsearch is now in. And Dependerbot is a very cool open source application or tool for open source project. And it will automatically create pull requests if dependencies of you have updates. So you're trying to keep your dependencies up to date all the time. And you can have different strategies if they should be auto-merged or if minor changes should be auto-merged. And yeah, thanks to this, now Dependerbot is the third highest committer. So he's better than me now. Yeah, like I get him automated away from the robots also now. All right. Yeah, then in version 1.11 we got support then for chaos testing, so ToxiProxy. ToxiProxy is a super cool tool where you can put this proxy between your containers and then introduce anomalies into your network stack, things like drop packages, latencies, and you can use it very nicely for chaos testing, chaos engineering. Postgres module is not using fsync flag anymore, means it became much, much faster. I don't even know what fsync is. I think it's for syncing up the state of the Postgres to the file system, normally not important for your ephemeral build nodes. Netty is out of it now completely. We're just using OK HTTP. Some shading stuff, okay, doesn't matter. This is a nice feature we also got now, depends on API, meaning you can now define dependencies between your containers. So a little bit like what many people think the depends on does in Docker Compose, but as contrast to the one in Docker Compose, it actually works, because the Docker Compose depends on will just lead to a certain start order. But the start order, as I said before, doesn't mean start order of the application, so just start order of these containers. If you use it in this API from Testcontainers, it will mean it will really wait for those containers to be started. And then some people say, okay, yeah, it shouldn't matter, like applications should be resilient, they shouldn't require other applications to be running. And yes, this is correct, but when you're integration testing against certain other dependencies that are not in your control, maybe they are not resilient. Maybe they require certain things to be running, and you can easily model it like this. Yes, we switched to a new CI system for Windows. So before it was a very, very big problem to run the CI for our Windows build. And since we have many things that are different on Windows, this was a very big problem. So sometimes we broke things, and then we got notified because Windows users were saying, oh, you broke Windows support in this way. So we had a hard time getting Windows support in there. In the end, the only way we could get working by using our own build nodes, our host, because most software as a service, Windows CI systems, either very expensive or the free ones didn't allow for using Docker in Linux mode. Lastly, maybe it's now changed, but back then, and we were in discussions with the Azure people, so they also said, okay, for what you need, you have to use your own build node. And this is now nice, so now we have CI for Windows running. Some new modules, DB2, Cockroach DB, RabbitMQ. DB2, we got people from IBM in helping us to support it. IBM provided a new Docker image for DB2 because the official one they had before was so legacy-like, was really not nice. And yeah, they really nice that they got in touch with us and fixed this. Okay, yeah, some more small things happening. When logging, we are more secure now, so we are not accidentally locking any credential details anymore. We have the Oracle JDBC driver now for our own tests, which is nice, but only possible because Oracle made it available in the public repositories. You have now something like image pull policies. You can see down here in this example. So this is when you are following this actually not so good practice of using something like a latest tag somewhere. But at least this way you can a little bit hack around it by saying, okay, I will use latest tag, although I know I should not do it, but I will at least say this latest has a certain expiry date. So every 1 hour I will then at least check if there is a newer latest. Yeah, not the best practice, but a way to work around certain limitations maybe of your team. And now, just in March, the new version is out, 1.13. And just a small change, so we got support for two new modules, Presto, OrientDB, and you can now, when you use Docker Compose container, also access the services by container name. So it was before it was not possible to get a handle on those containers that were managed by Docker Compose. Now it's possible and makes the Docker Compose integration even better, even higher feature parity. So since I'm running out of time, I try to quickly wrap up some stuff. I will not go into here in the future and common pitfalls, but I want to show you one more thing here, okay? As a new feature we now have in the alpha preview, which we call reusable containers. And it's actually in there since 1.12.3, but you have to consciously activate it. And it's only documented in this pull request and in the release notes somewhere. So you have to set this test containers reuse enable property in your test containers properties. And we will quickly look how this looks then. So then you can, I have basically the same test. You should not use a test framework integration in this case. You should use this with reuse true. This reuse true will only work if you also have this property set, and then you have to now manage the container by hand. So managing means just starting by hand. And now I do the following. I solve the test pollution on a logical level by just reinitializing the schema here instead of rebuilding the whole container. Okay. Now we run it the first time. Okay, first time already was much faster than before because there every time it took like 4 seconds every test. And now we have the container still running here, although the JVM exited. And now, yeah, now it's like much faster. So what takes the longest is actually starting the whole build, the Gradle interactions, but then the actual tests are super fast because they just reuse the running container, and this gives you a really nice, we call it ITDD, Integration Test Driven Development Flow, and very useful for, yes, just testing out your SQL queries or whatever. All right. Okay, and yes, many more things to come. Just talk to me, but I will leave soon to Istanbul, so you have to talk to me directly now after the talk. But we are working on Podman support. We are working together with Redman on Podman support. I'm looking forward to this coming. And yeah, there has been some drama in the open source world regarding Docker Java, like just 3 days ago. So we are using Docker Java. It's the main Java library for interacting with Docker. And we started to maintaining this also, but there has been some problems with the other one maintainer and our maintainer. So we will not go on working with Docker Java in the future. That's already what we decided. And then what happened now, the only maintainer that was left in Docker Java now quit Docker Java just yesterday. So Docker Java is basically kind of dead now. Not even on live support anymore. Docker Java is dead. And we rely on it, and many other projects rely on Docker for Java. So we are currently in the process of getting some people from the Java open source community that need a good Docker Java library together to solve the situation one way or the other. But I think the future is optimistic, so don't worry. All right, yes, so thank you very much. It was a pleasure to talk to you. And yeah, if you have any questions in the future, just ping me on Twitter, join our Slack, ask there. Also, if you have problems with test containers, we are very open to help everyone with the resources we have available. And thank you very much.
Any question?
Yeah.
Thank you very much for this very interesting talk. My question is, are there any advantages over using reusable containers instead of starting a container once at the start and just keep it running?
Yes, it will survive the JVM exit. If you start the container once at the start, it will still exit at the JVM exit because Ryuk will not get the heartbeat anymore and then kill it. And using this approach basically deactivates this feature in Ryuk, and instead, but this feature is not implemented yet to be honest, but instead it will get an expiry date attached to the container, basically saying, okay, if there hasn't been an interaction from test containers with this container for, let's say, half an hour, then we kill it. But this feature is not implemented yet, therefore it's still preview.
Okay, cool, thanks.
More questions? Okay. You are Java developers. You can use Docker. Okay, one starts a hackathon to porting the Docker Java.
Yeah, so.
Okay, you organize that?
Nice. Yes.
Okay. We find a room for that.
Yeah, sounds good, sounds good.
Yes. I can help.
Cool, yes.
Yes. Nice. Okay. Thanks.
Thanks.